Today's topic is elimination reactions, and in an elimination reaction either two atoms or groups are removed either from the same atom or from the adjacent atoms or somewhere else, means at least two atoms or groups are removed from the substrate molecule, and it results in the formation of a pi bond. So most of the time alkene is formed. So there are three types of elimination reaction, that is alpha elimination, beta elimination and gamma elimination. Alpha elimination means when two groups are lost from the same carbon atom and it gives a carbene. This is called 1-1 elimination. For example, Raymond-Timon reaction?
Yes, sir.
So in Raymond-Timon reaction, we use
This is a formation of dichlorocarbon.
yes, this is phenol in the presence of chloroform and NaOH. So first of all, what happened? We have H and Cl in the presence of OH negative ion. First, there is a removal of H plus. So it
Yes.
gives this anion, trichloromethyl anion, and at the same time Cl negative ion is removed from the same atom and we get dichlorocarbene. So this is alpha elimination reaction, and this dichlorocarbene is
Yes.
electrophile used in this Raymond-Timon reaction. Now in beta elimination, when two
It's a
sorry, hello,
It goes to ortho and para position.
yes, because it is now gives electrophilic substitution reaction. So major product is ortho because it form hydrogen bonding. Now when two groups are lost from adjacent atoms, again there is a formation of a pi bond, and this is called 1-2 elimination. This is most common, 1-2 elimination. Yes. So all the reaction like even in the presence of concentrated H2SO4, or even if we have H and Cl in the presence of alcoholic KOH, we get alkene, we get alkene. So these are beta elimination reactions. There are third type of reaction, that is gamma elimination. It is called 1-3 elimination, and it leads to the formation of three-membered ring. So
Sir, examples of this one?
there is a
Cyclic esterification.
cyclic esterification. Yes, that may be the one of the reaction, or sometime H and OH are removed from different atoms and a cyclic lactone is formed. That is cyclic ester. Okay.
All right.
E1 reaction. So E1 reaction, in E1 reaction, one H plus ion and a leaving group that departs into different steps. In first step, it involves the formation of carbocation, because
Yes.
in the presence of solvent, generally solvent used in this case should be polar protic solvent.
Yes.
Polar protic solvent should be used so that the cation formed is hydrolyzed, or we can say solubilized, so that it is stabilized by the presence of polar protic solvent. Means polar protic solvent favor this reaction, and then after the removal of this group, that X and here see base comes in the second step, right?
Okay, sir.
First step is due to solvent only, right?
Yes.
So there should be a good leaving group, first condition, and solvent should be such that can solubilize the carbocation formed. Okay, so solvent should be polar protic in nature. Now in step 2 base comes, that means base should be weak, because the base is not attacking at the same time. It first wait for the formation of carbocation, and say first step is also rate determining step. That means
Yes.
rate of even reaction is follow first order kinetics, because it is slow step. Formation of carbocation is a slow step. Now base abstracts a proton. So when this base abstract a proton, it leads to the formation of alkene, and condition is this base should be weak. Then only it will wait for the formation of carbocation. Okay.
Okay, sir.
So it is a two-step reaction. Follow first order kinetics. Formation of carbocation is a rate determining step. So that means the alkyl halide, which leads to the formation of more stable carbocation, that is more reactive. So tell me which alkyl halide should be more reactive?
Tertiary, sir.
Yes, the order of reactivity is tertiary, secondary, primary.
All right.
Due to the formation of a more stable carbocation in tertiary. And at the same time, as carbocation is formed in the first step, there may be rearranged product,
Yes.
because first most stable carbocation is formed and then abstraction of proton takes place.
Yes.
So what are the characteristics? First of all, it is a unimolecular reaction, because in the rate determining step only one molecule is involved. It is a two-step process. It follows first order kinetics. Reaction intermediate, as it is carbocation, so rearrangement is possible. Means rearranged product we can get. And in the second step, the base removes the proton, attack on the proton from the carbon atom adjacent to the carbocation, and therefore it forms alkene. And kinetics involved is, it is follow first order kinetics. Now free energy diagram of E1 reaction is similar to that of SN1, because SN1 as well as E1 both takes place in two steps. Both leads to the formation of carbocation. Only second step is different, because in the second step in SN1 nucleophile attack from front side or back side, but here the reagent used is added is act as a base, and therefore it abstract proton from it. That's why again there are two transition states. In the first transition state, C and X bond starts moving away from each other. There is a stretching of CX bond. This is a stretching of CX bond, and therefore that is first transition state. And when this bond breaks, we get carbocation. This is reaction intermediate, and then again base will abstract hydrogen from it, and therefore we get alkene. So base starts attacking to H, means the first transition state is like this. It starts moving away from it. And second transition state is breaking of H, attachment of the base, and formation of a double bond. This is second transition state and alkene is formed.
Yes.
For example, this is the example here, bromine is attached to tertiary carbon. So first of all, in the presence of solvent, see, that is polar protic solvent, and on heating, first we get the carbocation, then this methanol will abstract hydrogen, and therefore double bond is formed and we get alkene as the product.
Understood.
Again, here it is primary alkyl halide, but again methanol solvent, and see, heat is also required, because here we lead to the breaking of bond, and therefore carbocation is formed. When carbocation is formed, it is primary carbocation actually, and it is attached to tertiary carbocation, tertiary carbon, sorry, and therefore there is expansion of ring expansion. Whenever positive charge is attached to the atom, directly attached to the ring, and ring is of 3, 4 or 5 membered, that will leads to the expansion of the ring, and therefore ring expansion takes place, and because of that this carbon gets positive charge, and after removing this, either hydrogen is removed or methanol will attack at this position, and therefore we get two products. Again, next, OH group, it is protonated due to the presence of H plus, H2O positive is formed. It is a good leaving group, so H2O is removed, and therefore we get carbocation. And now this methyl, along with its electron pair shift, this is called 1,2 methyl shift, and therefore we get this product, alkene as the product. See, this is a ring expansion, now this is one of the reaction. Ethanol is, it is a base, and heat. So when ethanol, when we heat it, what is the major product formed? First of all, there is a formation of carbocation.
Yes, sir.
Then obviously this is secondary carbocation.
Yes, sir.
So this secondary carbocation can be converted into tertiary carbocation due to 1,2 hydride shift.
Yes, sir.
So whenever carbocation is attached to tertiary or quaternary carbon, then either 1,2 hydride shift or 1,2 methyl shift takes place to get tertiary carbocation. So we get tertiary carbocation, and therefore there is one hydrogen as well, so that hydrogen is removed and we get the major product as B. So B is the major product, right? Got it? Yes, but because alkene formed should be more alkylated, and it has C 3, 3, 3 and 2, total 11 alpha hydrogens.
Okay, yes, sir, understood.
More the number of alpha hydrogens, more stable is the alkene.
Yes, sir, that's what I was checking.
Okay. In this case, you know, there is only one hydrogen, alpha hydrogen.
Yes,
In this is also formed to some extent,
the minor product.
minor product. Even this can be formed as minor product.
Yeah,
This
here
all
minor products, right?
all can be formed as minor products.
Oh,
Okay. But in this case, see, there is 3 plus 3 plus 1. 7 alpha hydrogens. So maximum alpha hydrogens are in the B part. Yes. What is the product formed? Very simple question.
okay.
Yes, tell me.
Option
Very good. It is option A, because first of all, you know, there is a removal of OH due to the presence of H2SO4. So it leads to the
Yes.
formation of carbocation, and carbocation formed is tertiary. So there is no need of rearrangement, and therefore hydrogen is removed from the neighboring carbon, and to form more alkylated alkene, this is the major product. Okay, what is the reactivity order of alkyl halides in the even reactions?
So tertiary would be most.
Yes, tertiary more than secondary than primary.
Yes.
And in case of different halogens, you know, iodide is more than bromide, then chloride, and at the end it is fluoride.
Alright.
So obviously B option is true. Yes, tell me, what is the product formed? So just look at this.
Yes, sir. Option C, sir.
Why not B?
B has fewer alpha hydrogens, sir.
That's true, but once you will get this carbocation,
Yes.
okay, you will when this carbocation is formed, okay, yes, so C is the major product. Yes,
Balance. Okay.
oh my god, this is wrong, because Br is attached, Br is now here, okay, by mistake it is taken.
No,
Okay,
sir, this is ये उल्टा जा रहा है ना. You have to identify A कि
oh, sorry, okay, got it. Okay, we have to find out the alkyl halide.
Yes, sir. Can't be D, sir.
D?
D, it can't be D, sir.
Okay, okay, okay. See, it can't
I
be
think
A.
it is A.
It can't be A because see, if it is the compound, we get this carbocation, and this carbocation is attached to quaternary carbon. So
Yes.
there is 1,2 methyl shift
Yes.
to form more stable carbocation. Got it? So it should be like this.
So, yes. So it will be B then, sir.
Yes, it is B because when we form its carbocation, see, the carbocation formed in this case is stable, right?
Yes.
And if we do the 1,2 hydride shift even, then it is again secondary, but less stable than the one which is already formed, and therefore
Yes.
there is a
General carbocation.
yes. So that's why this one is the correct option.
Oh,
Yes.
what is OTS?
This is tosyl, that is very good leaving group, that makes it very
Oh,
good leaving group.
uh, just option D, sir.
Option
D.
very good. It is D because first OTS, this is from carbocation, and
Yes.
hydrogen is removed from the neighboring. Even reaction is favored by
Good leaving group.
yes, good leaving group, because non-polar solvents, it is not a is possible to get this reaction in non-polar solvent. Strong base is not required because that leads to the formation of a E2 reaction,
Yes.
because here base comes in the second step if it should be weak. Among the following poor leaving group, so it should be fluoride.
Yes, sir.
Okay, now E2 reaction. So in E2 reaction, the dehydrohalogenation is one of the reaction. It leads to the removal of hydrogen and halogen in a single step, that is called concerted mechanism, because both the groups are removed in the same step. So dehydrohalogenation can take place by even an E2 mechanism. So first is hot alcoholic solution of KOH. ETO negative means potassium ethoxide, ethanol, sodiamide, or tertiary butoxide, or in tertiary butyl alcohol. So see, this transition state is formed, base starts attaching to beta hydrogen, and carbon carbon double bond formation starts, and CX bond breaking starts, and that is called a transition state. So see, in E1 there are two transition states and one reaction intermediate.
Yes.
But in E2, there is only one transition state, no reaction intermediate. So leads to the formation of alkene, halide, and base. So this is a single step bimolecular reaction. It follows second order kinetics. Reason being, alkyl halide and base are in the same step, appearing in the same step. Rearrangement is not possible here, because to get rearranged product we should have a carbocation, but here there is no formation of carbocation. Now for the lower energy of activation, transition state must be stable. So transition state formed should be stable, and E2, yeah, this concerted mechanism. And there should be orientation of proton and leaving group in anti-periplanar direction. Means if one is in stereochemistry, if we go, then if one is on the above the plane, other should be below the plane.
Yes. Below the.
Then they can, means it should be oriented in such a way. Here beta hydrogen is eliminated by base, and this is called beta elimination. Now positional orientation of elimination. You know, in both E1 and E2 eliminations, there are two or more possible elimination products. So which product is most favorably formed? The more alkylated alkene, yes, more highly substituted double bond, that dominates. And this rule is called Setjeff rule or Jetsev rule. Like say dehydrohalogenation of 2-bromo 2-methyl butane, it gives two products. Say with respect to this alpha hydrogen, we have two beta hydrogens. So if we remove, means poor becomes poorer, that is called Setjeff rule. Means the one which has lesser number of hydrogens, that is decreased, and that leads to the formation of more alkylated alkene. And if less alkylated alkene is formed, that is called Hofmann's product, and most probably this one is the major product. There are some conditions where Hofmann product is dominating, that is means Hofmann elimination is not in our syllabus. So whenever the product is formed, that is by Setjeff rule only.
Alright.
So see, first there are reactants, alkyl halide and base. Now this base attacks at beta hydrogen and leads to the removal of beta hydrogen, right? And at the same time, carbon-carbon double bond is formed,
Yes.
and Br is removed as Br negative. If it is more stable, say in first case it is less stable, so its activation energy is high. If transition state is less stable, if transition state is more stable, its activation energy is low, and therefore we get two products. This is more stable product, thermodynamically more stable product, and this is less stable product. Reactivity order is same in E1 as well as E2. Even the order is same: tertiary, secondary, primary, because more alkylated alkene is more stable. So see, beta hydrogen, here beta hydrogens are 3. In this case there is only one beta hydrogen, and therefore poor becomes poorer, means more alkylated alkene is more stable.
Alright.
The second case, there is only one option. This Br is removed and there are same types of beta hydrogens. Only one product is possible. Hoffman product is formed. There are some when base is very bulky. So when we have bulky base, you know, it cannot attack a hindered beta hydrogen. Okay. So in that case, you will get the less alkylated alkene as the major product. See the difference. Both reactants are same, but here base is less bulkier. In this case, base is bulkier and therefore it gives steric hindrance and therefore less hindered product is formed. So major product is alkene. That is the case. Okay. If we see the stereo specificity of E2, as I said earlier, that it should be anti. Bromine and hydrogen, they should be anti and coplanar. They should be in the same planar but in the opposite direction. So there are different diastereomers of starting materials and they give different diastereomers of alkene. See, we have, this is Fischer projection formula. Keep in mind, Fischer projection formula is always a eclipsed conformation.
Okay.
Of Newman projection formula. So see,
Okay.
this phenyl, bromine, hydrogen, methyl. So we can rotate it so that we will get a staggered conformation. See, this bromine comes on this side, this hydrogen here, and phenyl at this position. And this one, hydrogen, phenyl, methyl. So we rotate them in anti position. So base, hydrogen and bromine, they are removed from anti position. And in this way, we have phenyl, hydrogen, methyl, phenyl, and leads to the formation of alkene. So it is methyl phenyl, and on the other side it is phenyl and hydrogen. So always first we orient them in such a way that they should be anti to each other and in the same plane. Okay, so based on the Setzeff rule, the most stable alkene is, which one is most stable? This is A.
Yes, sir. A is most stable.
Yes, A is most stable. So this is the right option. What about this? Bromine is towards the observer. So this hydrogen should be away from the observer.
Yes.
Because it is towards the observer right now. Okay. So we have to rotate it.
Yes.
In such a way that hydrogen is away from the observer. So phenyl comes on the same side.
Okay.
That's why B is the right option.
Understood.
So now your job is just to solve questions related to elimination reaction. Okay. Send me at least 15 questions.